What's up, interweb? Excuse me. This is the material we went over on September the 1st. That was Wednesday, and it's all about exponents. Now, exponents look like this. This is the base number, and of course, that's the exponent. Now, the exponent, excuse me, tells how many times the base number, that one, is multiplied times itself. So in this case, 5 squared is how many times do you multiply the base number, that's this, times its own self? That's what we say in North Katy. So we're going to take 5 and we're going to multiply it times itself twice. 5 times 5 is 25. If you forget, your brain goes numb, put it in the calculator. It'll do it for you. Now, 3 to the 4th power is 3 times 3 times 3 times 3. 1, 2, 3, 4. 4 times. You multiply the base number times itself. So 3 times 3 is 9. Times 3 is 27. Times 3 is 81, I think. Okay, and again, if you forget, put the number in like this. 3. Put this in the calculator. There's a little caret looking thing that means raised to the 4th power. Now, what if we have this? Negative 4 squared. Now, is this negative 4 times negative 4? No. Remember, this is order of operation. What is this really saying? Subtract 4 squared. So this is equal to negative 4 times 4, was it 16? Negative 16. Now, if it's in parentheses, negative 4, remember the parentheses makes this one number. Now, if we make that squared, now we have negative 4 times negative 4. A negative times a negative is a positive. 16. Am I right or am I right? I'm right. I'm always right. Well, if my ex-wife was here, she'd be rolling her eyes right now. Now, this is one of these things that really doesn't make a whole lot of sense at first. But if you have any number, like x can be 15 billion, raised to the 0 power is 1. Seems like it ought to be 0, doesn't it? Well, it's not. It's 1. And we'll prove this a little bit later. Now, I think I sent everybody a sheet on how to, all the rules for exponents and all that stuff. But if the base numbers are the same, for instance, a to the 5th times a squared, base numbers are the same. So what do we do with the exponents? The base number remains the same. We add the exponents. So this is a to the 7th power. Okay, base numbers have to be the same. And then we would add, if we're multiplying, we add the exponents. And same thing if we have 15 squared times 15 to the 4th power. Base numbers remain the same, so and we just add the exponents. 2 plus 4, which is 15 to the... You don't need to do this. I just do it just to show everybody how it's done. Okay? Very good. Now, that's if we multiply. Now, what if we divide? What are we going to do with the exponents? Excuse me. Right, we're going to subtract. So, but again, the base numbers have to be the same. So if we have b to the 5th over b squared. Now remember, the fraction bar means divided by. So when we divide exponent or numbers with the exponents, and the base numbers are the same, this is b to the 5 minus 3, which is b to the b squared. Right? Right. Now, what if the larger number's on the bottom? What if we have c to the 4th over c to the 7th? This is we're going to subtract the exponents. Now there's more of them in the bottom. This is actually 4 minus 7, but we're going to take the difference between these numbers. That's c cubed, right? There's more of them down here. Now what goes in the numerator? 1. Now let me show you why that is. If we have c to the 4th is c 2, 3, 4. And on the bottom we have 1, 2, 3, 4, 5, 6, 7. Any number divided by itself is 1. So c divided by c, why is my big fat hand in the way? Let's see if this is any better. C divided by c is 1. Right? Any number divided by itself, 15 billion divided by 15 billion is 1. And again, c divided by c is 1 and 1 and 1. So what do we have left? C times c times c, which is c cubed. Now, what's in the numerator? All these are 1s, so we have to have the 1 in the numerator. Okay? Okay. Mm-hmm. Now, what if we have this? If we have, why is my big fat hand in the way? If we have 9 cubed divided by 9 to the 5th, this is 9 times 9 times 9, right? Base number times itself 3 times. Same thing here. 9 times itself 5 times. 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4. 9 divided by 9 is 1. 9 divided by 9 again is 1. 9 divided by 9 is 1. So what do we have left? The numerator is 1. The denominator is 9 times 9 is 81. 1 over 81. Right? Right. Okay. Everybody okay with that? Okay, now what if we have negative exponents? N-E-G-A-T-I. Negative exponents. Okay, so what if we have this? What if we have a to the minus 5 divided by b to the minus 3? Now these are not, the base numbers are not the same, so we can't, sorry. The base numbers are not the same. This was an A, this one's a B. So they're not the same, so we cannot combine these in any way. However, negative exponents, if the exponent is negative, move it. Okay, where do we move it? If it's in the numerator, move it to the denominator. If it's in the denominator, move it to the, or if it's more simply, if it's in the top, move it to the bottom. And if it's in the bottom, move it to the top. If I were you, I would take these one at a time and take your time with it. I do this misery all the time, and I still make mistakes with this because I'm stupid. Okay? But draw the fraction bar. A to the minus 5, where does it go? Goes to the bottom. And then the exponent becomes positive. Okay? Now we take the next one, b to the minus 3. Exponent's negative, so it goes to the top. B to the... Okay, now the instructions you're going to get on tests and on the final are evaluate, E-V-A-L-U-A-T. Just means find the value. Evaluate with all positive, S-I-T-I-V-E, stupid boy, exponents. Evaluate with all positive exponents. Okay? Okay. And if we have this, oh, now the denominator cannot equal 0, otherwise we get an undefined answer. We'll talk more about this probably in another month or so. And if you have, let's see, a to the minus 3, b to the minus 2, c to the 5th, divided by a squared c to the negative 4. Now this is about as difficult as these get, and it's really not very hard. But again, take these one at a time. Draw the fraction bar. Now a to the minus 3, where does it go? Because it's negative, it goes to the bottom, to the denominator. And the exponent becomes positive. Same thing with b squared. Goes to the bottom. The c to the 5th, it's already positive, so we're going to leave it where it is. Okay? A squared, same thing. It's the exponent's already positive, so we're going to leave it at the bottom. C to the minus 4 goes to the top and becomes positive. Now, c to the 5th times, if there's not a plus or a minus in here, this means to multiply. Now, what do we do when we have the same base numbers and we're multiplying? We add the exponents. That's c to the 9th. Is that right? Yeah. Now we have a and a here. So it's going to be a to the 5th because we have the same base numbers. We're multiplying, so we add the exponents, and b squared. Anything else we can do there? Not a thing. That's all. Now, the power rule. If you have, excuse me, if you have d squared over e to the 5th raised to the 3rd power. Now, when you have a power, when you have an exponent raised to an exponent, a power raised to a power, you multiply. You multiply the exponents. So this is going to be d to the 2 times 3, and this is going to be e to the 5 times 3. We're going to multiply each one of these. When you have a power raised to a power, multiply. So this is going to be d to the 6th over e to the 15. Is there anything we can do there? No. Okay. Now what if we have this? If we have 3 over 4 raised to the negative 2 power. Now what are the exponents on these two? They're 1. We just don't write it. So this is going to be 3 to the negative 2, multiply the exponents, over 4 to the negative 2. We're going to multiply everything by negative 2. Now how do we make the exponents positive? If they're negative, move them. So 3 to the minus 2 goes to the bottom and becomes positive. 4 to the negative 2 goes to the top and becomes positive. Now we can deal with this. 4 squared is 16. 3 squared is 9. Can we reduce this fraction? No. Okay. I'm sorry about cramming this together, but I have a problem. It's a personal problem with wasting paper. I don't know what it is. A over 4b all raised to the negative 2 power. Okay, so what do? We're going to distribute the negative 2 over every one of these terms. Now don't forget 4 is a term also. So it's going to be a to the minus 2 over 4 to the minus 2 times b to the minus 2. Everything gets multiplied, or the exponents get multiplied by negative 2. Okay, a to the minus 2 goes to the bottom, a squared. 4 to the minus 2 goes to the top and becomes positive, and b to the negative 2 goes to the top and becomes positive. Now the only thing we can do here is we can evaluate this. 4 squared is 16, b squared over a squared. There's nothing we can do with the a and the b because the base numbers are not the same. Okay? We already did that. Okay, one more thing and then I'll let you go. They get the problems like that, they get a little bit longer, but they really don't get any more difficult. Okay, this is the distributive property of multiplication. C-A-T. Are you all impressed with my spelling? I'm doing better. Okay, distributive property of multiplication, super duper whiz bang important. Very, very important. So if we have this, if we have 3 open 2a plus 5b, remember, the parentheses makes this one number. This is one number. So we're going to multiply the 3 times this one number. The only thing is there's 2 numbers in there. Sounds like I'm lying, doesn't it? Okay, and I'm going to multiply everything inside of the parentheses times 3. So this is going to equal 6a. 3 times 2a is 6a plus 15b. Can we combine these two things? No, they're not like terms. And again, this is an expression. Remember from day one we talked about that. Okay? This is very, very important. And what if we have this? If we have 5c times 2c squared plus 4. Now again, we're going to take the 5c not just the C, the 5C. Excuse me. Times everything inside of the parenthesis. 5C times 2C. First of all, 5 times 2 is 10. C times C squared. Now we have a common base number. The base numbers are the same. So we add the exponents. The exponent there is a 1. C times C squared is C cubed. And we do 5C times 4. Don't forget the plus in there. Plus 20C. It's not C squared. Remember, we're multiplying 5C times 4, and that's what we get. Can we combine these two things? No, they're not like terms. For them to be like terms, the variables have to be the same, and the exponents have to be the same. Okay, they really don't get any more difficult than this. They just get longer, but all the idea is exactly the same. Okay, I'm gonna put this up on YouTube's very soon. All right, y'all take care. Bye bye. Bye, Bonds.